Welcome to Ask Prep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is ray optics, reflection, refraction, and lenses. Ray optics helps us understand how light behaves when it interacts with different surfaces and mediums. This topic plays a critical role in understanding vision, lenses, mirrors, and the way light travels. Let's start with reflection, one of the fundamental concepts of ray optics. Reflection occurs when light bounces off a surface. Imagine you are standing in front of a mirror, and you see your own reflection. This happens because the light rays that hit the mirror bounce back to your eyes. Reflection can happen on any surface, but it's most commonly observed on smooth, shiny surfaces like mirrors. When light strikes a reflective surface, it does so at a particular angle, known as the angle of incidence. After hitting the surface, the light ray bounces off at an equal angle, known as the angle of reflection. This is known as the law of reflection, which states that the angle of incidence is always equal to the angle of reflection. This principle is not only applicable to plane mirrors but also to curved surfaces like concave or convex mirrors, which we will explore in more detail. Concave mirrors, for example, have an inward curved surface that converges light rays, meaning they focus light to a single point, which is called the focal point. This is why concave mirrors are used in applications like shaving mirrors and satellite dishes, where a focused image or signal is important. On the other hand, convex mirrors, with their outward curved surfaces, diverge light rays. They create virtual images, which is why they are commonly used for rear-view mirrors in vehicles. Convex mirrors provide a wider field of view, allowing drivers to see more of the road behind them. Now, let's move on to refraction, another important phenomenon in ray optics. Refraction occurs when light passes from one medium to another, like from air to water, and bends as it changes speed. This bending happens because light travels at different speeds in different materials. For example, light moves slower in water than in air, so when light enters water, it bends towards the normal line, which is an imaginary line perpendicular to the surface. One of the most common examples of refraction that we encounter is when a straw appears bent when placed in a glass of water. This happens because the light rays coming from the straw are refracted as they move from water to air, making the straw look displaced. This principle of refraction explains many optical devices, including glasses, microscopes, and telescopes. The degree of bending depends on the difference in the speed of light between the two mediums and the angle at which the light enters the new medium. This relationship is described by Snell's law, which is crucial in understanding how light behaves as it moves between materials like air, glass, or water. In fact, refraction is the reason why lenses can magnify objects, which we will discuss shortly. Speaking of lenses, let's talk about them in the context of lenses and their role in ray optics. Lenses are transparent objects that bend light rays passing through them. There are two types of lenses, concave lenses and convex lenses. Convex lenses, which are thicker in the middle, cause parallel light rays to converge at a focal point. These lenses are used in magnifying glasses, cameras, and even in corrective glasses for far-sightedness. Concave lenses, on the other hand, are thinner in the middle and cause light rays to diverge. These are commonly used to correct nearsightedness. When light passes through a convex lens, it can either form a real image or a virtual image depending on the position of the object relative to the focal point. If the object is placed beyond the focal point, the image formed is real, inverted, and reduced in size. If the object is placed between the focal point and the lens, the image formed is virtual, upright, and magnified. Convex lenses are extensively used in optical instruments like microscopes, cameras, and even in our eyes. The human eye has a convex lens, which helps focus light onto the retina, allowing us to see clearly. Concave lenses, as we discussed, diverge light. They are primarily used in optical devices like eyeglasses for nearsightedness, where the goal is to spread the light rays out so that they focus on the retina properly. Concave lenses help correct vision by making distant objects appear clearer to the person looking through them. Another important concept to understand is the focal length of a lens, which is the distance between the center of the lens and its focal point. The focal length determines the lens's ability to converge or diverge light. A short focal length means the lens is more powerful, as it bends light more sharply. A long focal length indicates a weaker lens, as it bends light less sharply. The focal length, along with the curvature of the lens, affects how the image is formed. When light passes through a lens, the way the light rays converge or diverge depends on both the lens's curvature and the object's position relative to the lens. Understanding these principles is essential when you study optical instruments and devices that use lenses, such as microscopes, telescopes, and cameras. Ray optics plays a crucial role in understanding how light behaves in different situations. Whether it's the reflection of a mirror, the bending of light through a lens, or the refraction as light travels from one medium to another, these principles help us understand the nature of light and how it interacts with materials. These concepts have wide applications in the real world, from vision correction and photography to understanding the functioning of telescopes and microscopes. To summarize, reflection and refraction are fundamental to how we perceive the world around us. The study of mirrors, lenses, and light's behavior through different mediums helps us understand the mechanics of optical systems, both natural and man-made. Ray optics is the foundation of many technologies that shape our daily lives. Whether you are looking through a magnifying glass, using a camera, or wearing glasses, you are interacting with the principles of ray optics. I hope this video helped clarify some of the key concepts of ray optics, including reflection, refraction, and the behavior of lenses. Keep these ideas in mind as you continue your NEET preparation, and remember, mastering the basics of optics is essential for understanding how light interacts with the world. Thank you. Stay tuned to Ask Prep for more insightful content. Best of luck with your studies, and we'll see you in the next video.